My name is Julia Bush, and this is my test 2 wrapper. So the problem I struggled with the most was problem 3, and specifically part B. So for this problem, we're given that there is a sphere that is a conductor that has a radius RA and a charge plus 2q within a shell that is also spherical with radius RB and charge negative q. So for this problem, or for this part of the problem, we're asked to determine the potential difference between the point inside of the center of the sphere and a point an infinite distance away from the shell in the sphere. So first we have to define the potential difference in different regions given in this problem. So for the first region, we can see that inside of the sphere, the change in potential difference is going to be 0 because it is inside of a conductor, so there's no electric field and no potential difference. So between the sphere and the shell, or at a distance between RA and RB, the change in potential difference is going to be VRA minus VRB, which is equivalent to 2q over 4 pi epsilon naught times 1 over RA minus 1 over RB. And then outside of the shell, we know that the net electric field is going to be the electric field of the sphere plus the electric field of the shell. So this is going to be equal to k times 2q over r squared minus kq over r squared. So for our final answer, we have to add all of these different parts together. And we do this by stating that the potential difference inside of the center of the sphere minus the potential difference at an infinite distance away from the shell in the sphere is going to be equal to velocity in the center of the sphere minus VRA plus VRA minus VRB plus VRB minus V infinity. And we can see that the potential differences of RB and RA cancel out to make it equivalent to the left side of the equation. So for the first part of this expression, we know that velocity at the center of the sphere minus velocity RA is equal to 0 because it's inside of a conductor. And then we also found VRA minus VRB on the previous slide, and that is 2q over 4 pi epsilon naught times 1 over RA minus 1 over RB. And then for VRB minus V infinity, we can set that equal to q over 4 pi epsilon naught times 1 over RB minus 1 over infinity. And since 1 over infinity goes to 0, we can say that it's equal to q over 4 pi epsilon naught times 1 over RB. So our final answer is going to be all of these separate parts added together. And if we distribute the 2 into the 1 over RA minus 1 over RB, we can simplify this to be equal to q over 4 pi epsilon naught times 2 RA minus 1